I think that's it, Michael. It's your show.
All right, thank you, Roland. Everyone hear me okay? We're good, Roland?
Yep.
Okay.
Coming in good.
So, yeah, thanks for joining us. Tonight, I thought I'd just show part of this will be showing NINA, but also some of it will just be showing kind of what I would be doing at this time of night to get ready. What's on the screen right now is the C8 that's out back on my deck. And the Mach 1, it's all set up with a monochrome camera and a filter wheel. And I just wanted to show I've got my cables. I've got a piece of wire, a stiff wire. It's leftover housing wire, so it's like 14 or 16 gauge. And it kind of routes all these cables down and they hang, but then I have another piece here. So hopefully most of the weight of the cables is being held here. And then I have enough loose cable that this can go on both sides of the mount and it won't ever get hung up. So that's something important to think about when you're setting things up. Here's the closer picture, kind of have those cables run down. And you can see the rat's nest kind of here with all the cables there's a stepper motor on the focuser, and there's cables for the camera. There's a cable for the filter wheel. You can't see it, but there's an off-axis guider on the other side with another cable. You can see it better here. So I've got an off-axis guider coming in. We've got a monochrome camera, filter wheel, reducer. Here's a stepper motor running the focuser. And then on top, I've got this hub that allows me to run, I only have to run 2 USB cables to my mount. This blue one, which is USB 3, which is dedicated to the imaging camera on its own port, and then another USB cable to this hub, which goes to the guide camera, filter wheel, and this ugly thing here is my focus controller that I built. So, and then I have a 12-volt power line going up here, which powers this hub and the focus controller and the cooling on the monochrome camera. So when I'm done, I wrap all these cables up and just wrap them around the top. I never take anything off or take anything apart. So if it's clear, I can just pick it up, have it on the mount, and I'm ready to go. On my other scopes, I have a similar setup where I've duplicated the hub and the focus controller. I don't have a camera for each telescope yet. I'm not rolling, but I'm getting there.
Michael, have you noticed any difference with the separate USB for the camera? I mean, I've done it both ways and I couldn't really tell. I
always had USB issues if I did not make the USB 3 camera alone. So my laptop has 2 USB and 2 USB 3 and 2 USB 2. So I have the mount. I have the hub on top of the telescope going to one of the USB 2. I have the mount going to the other, and then the camera, the ASI 1600, goes to the USB 3. It's been pretty solid, so I didn't really tinker.
Sure.
But I suspect some of that's just laptop idiosyncrasies also. USB seems to always be troublemaking. So,
Michael, question?
Yeah.
How are you connecting all this to the scope itself? What is the thing that's connected to the scope, to the C8 that you put all the stuff on? Because I need something like that. That's what I'm wondering about.
On the back?
Yeah. What is the?
Well, it has a rail on top. One of those D plates.
What rail is it? I haven't been able to figure out what rail for a C8.
When I bought this C8, I bought in 2003. So whenever I bought it, I've got whatever Losman he sold to put on there.
Okay.
And then these gray things are just Losmandy sized. I don't know what you call that part. They slide on there and you tighten them. I just 3D print those because they aren't holding any weight.
All right.
Right. They're just holding a little hub. So I just blue tape it on there.
Right. Okay. All right.
But yeah, it's just a standard rail. I used to I can put a guide scope there. In fact, when I set this up earlier, I had a little guide scope up there so I could run sharp cap. To the field of view of this setup is too small for sharp cap. So I put that on there temporarily and then took it off. And then.
Okay.
Chris asked if the deck shakes.
What's that?
Chris asked if the deck shakes.
If I'm on it, so that's why I use remote desktop. No, it doesn't, surprisingly. Even when it's windy, I haven't had any problems with that. So I'm happy about that. All right, so let's switch over to NINA. Let's see, where's that? Hopefully this works. Everyone see NINA?
You got it.
Yep, okay. So I'm running an astrophysics mount, and it has a really nice kind of control center for everything. And it has this 3D view, so you can always see where you're pointing, which helps when you're inside trying to keep up with what's going on. But usually I keep all that closed because I'm just setting it up and it's imaging. So usually the first thing I would do at the beginning of the night is, everyone familiar with Carte du Ciel? That's the planetarium program. I would load it up and type in a target. You can see I've gone to plenty of them here. And so we're sitting here. I've already slewed to it, but I would slew the M66. Usually I do it manually. Just to get that first slew out of the way, I can watch the scope, make sure there's not something screwy with the calibration. But then in NINA, we talked about this the other night, but in case someone wasn't here, NINA is a free piece of software. It's getting a lot of development. It's good enough you can use it for big projects. Actually, I was kind of surprised how far along it is. And its main navigation's over here on the left. And so you go under equipment. I'll just do a quick overview. You set up your camera, filter wheel, all these things. So here I have my 1600 connected, and I'm going to turn on the cooling now. So you can see I'm going to target -15 tonight, and the current temperature is 9. So this is all Celsius. And you'll see down here the cooler power is starting to ramp up, and hopefully this temperature will start going down. And I have it set up right now. This min duration, you can have it so NINA goes down very slowly so it doesn't shock your camera. But the ASI camera has built-in algorithms to cool it at the proper rate. So if you set this to 0, it tells NINA just let the camera handle it. So you can see it's kind of gradually going down. For your filter wheel, you set up the names for all of them. I haven't done that yet. I kind of know them. Basically, they're LRGB, H alpha, O3, sulfur 2, and a dark. So I can take darks by turning the filter wheel. You set up your focuser. I don't have a rotator. That's something that would let you change the angle of the camera without going outside messing with it, which is kind of slick, but I don't have one of those. You set up your telescope. So it sees I have a Mach 1 connected. Here's PHD2, which shouldn't be doing anything yet, hopefully. I guess it automatically starts guiding when you connect. So the rest of this is flat panel, weather control. This stuff I don't have set up. So let's go to, next thing I would do is go to imaging and go to plate solving. So here let me turn PHD2 off. I don't want it running right now. Usually when you slew your scope for the first time, if you're really lucky, it'll be close to where you want, but it seems like there's always a little error. So you usually start your evening with a plate solve somewhere. I would not recommend doing it near the pole. Somewhere kind of closer to overhead or near the celestial equator is just a better behaved area to do that kind of solution. In NINA, you go to this imaging tab where I am right now, and this image tab shows you the latest image you've taken. You use autofocus to actually autofocus, and we'll talk about that in a minute. For the plate solve, you can go here and tell it to take an image, and it'll plate solve and figure out where you are. Here you can tell it if you want it to sync them out after it plate solves, and then if you click on this re-slew to target, it will try to get precisely on the last thing you slew the telescope to. I don't want to do that right now. I just wanted to plate solve and make sure that the calibration and the mount is good. So we just hit the start button there. It's going to take an exposure. It's going to solve it. It usually doesn't take too long. And so now it's done. So you can see earlier, like 8:45 here, I did some. And so this time it was right on because I've already plate solved it. But if it was the first one of the night, like this one down here, you could see I was off about 6 arc minutes. So any questions so far about the plate solving?
What solver is it using? Is it internal to NINA?
So let's see here. You have a choice here. You have lots of choices. I'm using ASTAP. It'll use All Sky, Plate Solve 2, astrometry.net, but I've been using ASTAP. It's really fast and it seems more reliable than Plate Solve 2 based on just my use. And it also can act as a blind solver locally, which is kind of nice. So now we're plate solved. If I go back to Carte du Ciel, you'll see we're dialed in on M66. So if I go back to NINA and go to image, if I just go over here, it's set up right now to take an 8-second exposure with the L filter, then 1 by 1 gain 76. I don't want it to loop. Loop means it will just keep taking it over and over and over. So you can just hit that if you just want to make sure you're pointing at the right place. And took a frame and it downloaded it. So there's M66. I think that's M65. So right now I'm not going to worry about perfectly framing this. The point is, you know, I'm on target. So now I'm going to run the autofocus. And what that's going to do is, here's the one I ran earlier. These numbers here are focus position and how big the defocus star is. And it'll start out here and away from focus, and you'll see the star gap bigger. And as it moves the focuser to several positions, then it moved it out of focus on the other side, and it fits this curve, the green line, and it allows it to determine the position of the best focus based on how these out of focus stars behaved. And you can see, you know, it kind of makes sense because these 2 points are actual measurements. So it seems to be in the right area. And then it will move the focus there. So we're going to do that. You just
a little flaky, Michael.
Sorry?
Your audio is getting a little bit flaky.
How is that better?
Yeah, it's good.
Okay. Yeah, I don't know if the streaming this desktop also interferes with that. Does this still sound okay?
Sounds good. Yeah, it was like 98% okay. It just was breaking up for a second there.
All right, I moved the mic closer to my mouth, so we'll try that. So we're running autofocus. It just took a frame and it measured it. So the 6 is the half radius of the star. This red line is an error bar. I haven't really worried about that too much. So it's moving the focuser in. So it moved from 8360 to 8285. So it's moving it from one side of focus into near focus, and you can see it start trying to fit that curve as we go along. So we had a question earlier before this about setting up autofocus. So the important thing is setting the step size between these samples. They need to be far enough apart that you're sampling this entire curve. And that's only something you can determine by experimenting. In my case, I focused the telescope using a Bahtinov mask. I just picked a value around 50 to 75 and then told it to run a curve like this. And the recommendation is that out here at the edge, that the size is somewhere between 6 and 8. And then it should go down between 3 and 2 in the middle. So I got pretty close. and you need enough samples that you're actually getting a nice curve. You don't, you know, if you took 10 samples and use a tiny step size, you would only get this area and it wouldn't be able to fit it very well. So it took a little experimenting, but as you can see, it's doing a fairly good job fitting it, and the curves seem, I mean, the points seem to be falling in a pretty reasonable pattern. I think I have it set up to do 4 or 5 on each side, so it should finish here in a second. Now I'm using really long exposures because I'm pointing somewhere that doesn't have a lot of bright stars in the field. If you were shooting somewhere like in the Milky Way galaxy, like Cygnus, you probably would not need these long exposures because there's lots of field stars there. All right, so it finished, and it moved the telescope back, and here's the final measurement. 3.34 is the size, which kind of matches the lowest point in this curve. Looks like it turned PHD2 back on for me. But so that's what a focus curve looks like. If you, as I said, you really want a range from around 6 to 8 at the far points, and it should obviously go through focus, and it should have many points along the curve. And this is very similar to setting up focus in Voyager or SGP. Let me stop a moment, see if anyone's got questions. All right. One important thing when you do this focusing is it's going to start over here. It moves through focus and then back out. And then when it determines a focus position, it's going to have to move back in the opposite direction to get there. And that involves, most focusers have backlash, which means when you change directions, it doesn't immediately start turning. There's a little bit of play. NINA has a nice tool, which I'm not going to run now because I got this figured out, but it will help you figure out how much backlash you need to put in, which is kind of slick. But once you get that number dialed in, you don't ever have to touch it again unless you change your focuser. So we're on target and focused. With NINA, this button I just clicked on means every time it takes a frame, it's going to measure the stars. So we're just going to take a frame to verify what we think the focus did for us. It'll update that every time a new frame comes in. And if you're taking a sequence, it'll start filling in this image history over here with those values so you can keep up with how things are going. So we're going to zoom in some. So you can see, you know, we're getting 3.19. These are stars that it measured. So they're all reasonable. They're not doing anything odd. If you move with this C8, I don't have a good corrector. So if you go out in the corner, you can see that the stars get bigger as you get further away from the center. For that reason, I usually only use about this part of the frame, which is fine. For the targets I'm shooting, that usually works out okay. So if we wanted to get start taking images here, let's start like we had never done this. So I'm going to go here and type M66 in this is the Sky Atlas. It's built into NINA. It's going to go out, sorry, that's the clear button. Here's the search. So it's going to search, and it found M66. It shows its altitude versus time during the night. So we're getting pretty close to it transiting. So the next step here, I could hit slew and it would slew to it, but I want to try to plan my exposure a little better this time. So I'm going to send it to what's called the framing assistant. And what this is going to do is download a sky image and then overlay the field of view of my telescope. And as you can recall, if we go back to the imaging, when we took a picture, we had my object in the center and this other guy was kind of off in the corner, which is kind of what we're seeing here. So I'd like to get both of them. So we can just slide the field of view over and then Down here, we're going to hit this replace as sequence. It's going to send those coordinates down here to the sequence planner, which is this next tab. And we're going to, this is the name it's going to use, so I'm going to call it M66. And it has the coordinates already. I'm going to set it over here. We set up a few things. I want it to start guiding when it starts the sequence. We'll have it slew there and center on it. And then we're going to have it focus on the start every time it changes the filters. And we'll have it refocus every, let's say, 70 minutes, because it's going to cool off some tonight. Now down here are the list of observations you want to take. It's very similar to all the other programs you probably use. In this case, I'm just going to do L filters. Let's just take some 30 seconds. And let's just do 15 of those or 10 of those. I'm not going to, it can control dither, but just in the interest of keeping things moving, I'm going to turn that off. And I'm going to make sure I have enough disk space. Yeah, let's see. Nope. Because the last time I used this machine, I'm not sure I cleared it. Oh, yeah, we're a little tight. It'll, let's see, I'll go here. Sorry, I should have done this earlier. We'll just kill this one.
It's just the Windows bloatware.
Yeah, all right, let's see, let's get rid of that. Okay, do we get enough space? Yeah, we got plenty of space. All right, so to review, we found the coordinates we wanted to go to using the framing tool, so I could get both those guys in there. When this sequence starts, it's going to turn on guiding. It's going to automatically find a guide star, and I'll show you that in PHD2. Before then, it's going to slew to the target to these coordinates. It's going to use plate solving to keep trying to slew and plate solving until it's very close. Then it's going to run a focus, which I'll turn off since we already did one of those. I also, if I were imaging L, R, G, B, then every time it changed the filter, it would do a focus. So now we can just hit go. So it's slewing the scope. We're going to go over here to imaging now. Now it's going to do this precise slew. So it's going to take a frame and plate solve it. So we got pretty close. You can see we got both these guys in there. Here's the error. So it was off 16 arc seconds, 16 arc minutes. So it's happy with that. So now you can see here, start guiding sequence. I'm going to clear this. So that means in PHD2, stop me if I'm jumping around too much, but I'm going to switch back to PHD2. So PHD2 found a guide star in the frame. Let's see, graph. So let's talk about PHD2 for a second while this is all running. This is how I usually have it set up. This bottom shows your RA and deck axes. This is these numbers going up and down are arc seconds, and you hopefully these curves stay near the middle. If they start to drift off to the top or bottom, your guiding's not working. This yellow line is the strength of the star. It's how bright it is. You enable those under here. I turned on star mass. So that's helpful if you're just watching this and then all of a sudden this thing starts doing something like going down and up and down and up. That means you got clouds or you're going behind the trees. So it's helpful to keep an eye on that. Up here it shows just a very close-up image of the star we're guiding on and then a cross section. You can tell it's focused. So these little bar graphs, the blue and the red, show the corrections. The other night, if you're on the thing I was telling Mike Mancini about, do you have the corrections turned on? That's this checkbox right here. So you can see it when it drifted up in RA, it started sending corrections trying to pull it down. Over here, when the deck was below the line, it tried to pull it up. And in this area where things seem to be behaving, it's not sending any corrections. So that's a good way to sort of diagnose your guiding, is to watch these corrections, because if this keeps drifting up and you don't see it sending corrections in the opposite direction, then that's kind of a hint something's not working. So, you know, seeing's all right tonight. I'm imaging this over my house, so there's heat coming off the house, so it's never good on this side, but we're about 0.5 arcsecond RMS, which is what I usually get when I'm shooting over the house. Any questions about PHD2? I can go into more detail if there's interest. I can talk about this brain a little. When you're guiding, PHD2 has different methods of handling corrections on right ascension and declination. Currently, I'm using the default, which is called hysteresis, which basically means it looks at the current position, but it also looks at the last few positions and uses sort of a combination of the error over time to make a correction. So if you had just one really far off measurement, it wouldn't immediately jump and follow that. It needs to see a few in a row before it reacts. And over here I have declination set on resist switch. Usually your declination actions, as you can see here, it's kind of drifting up, and then it hits a point and it does a correction to pull it back down. And then it's going to drift back up again and then get pulled back down. The resist switch tries to learn which way it's drifting, and it will generally only do corrections in the opposite direction. It helps with backlash if you have that on your deck axis. And I do have some backlash compensation enabled. It tries to learn. Well, let's say it was moving along here in deck and it sent a correction, and then after a few more samples, the thing hadn't moved yet. And then it sends another one and it moves. PHD2 kind of learns from that, going, well, if I change directions, I need to send a little extra movement to take out backlash. So I've set it so it can run from 20 to 350, and it's automatically kind of setting it. So it's kind of come about on this value based on guiding I've done so far. That can be handy if you have backlash, because if you're doing dithering and you have backlash, sometimes it can take a long time to run out that backlash, and you know, it might take a minute between frames when you dither, which is this time you're wasting. You could be imaging. So that's partially why I have this set up. Let's see, has anyone got questions so far? All right, so we've been guiding for a while, so we'll just put PHD2 away. And if we watch here, you can see that NINA duplicates that graph from PHD2, which is kind of handy. You don't even need to have PHD2 up. You can watch this graph. Over here is the image history. So we've taken a few frames now. The yellow line is the number of stars per each frame. And I'm not sure what the units are. They don't ever label it. The green line is the star size. And it started out pretty good, and it's kind of drifting up, which could be several things. But that's something you watch during the night. You know, if you see this thing start to drift up, that may mean you need to go and manually, you know, do an autofocus. The telescope could still be cooling off. I tried to not sit it out in the sun, but SCTs particularly take a while to cool off at the beginning of the night because they're closed, and I don't have any fans or anything set up, so all that air is kind of trapped inside it. So it'll take a while to cool off, but as you can see, we're getting, you know, if I zoom out and then we go back and look at how we framed it. No, let me load that. It may have lost it, but you know, I had it kind of framed like that. As you can see, it's inverted right now, but when we did if we do a pure flip, you'll see everything will rotate 180 degrees. Speaking of which, I need to make sure I have the pure flipped enabled. Where is that? Oh, here we go. So let's turn that on. We'll be brave. So what's an auto Meridian flip? So if we go back and look at where the telescope is, let's see, I think it's that one. you can see, okay, so this is east, here's west. So the telescope's moving this way, and at some point it's going to run into itself. So you don't want that to happen. So what we need to do is we need to flip the scope. So it's going to move the telescope to this side and point at the same place in the sky. But now the scope is on this side and will continue tracking to the west. You can do that manually, but NINA will do that for you. I think of where it is. Telescope. Right. So currently, if we look here, it says that we're going to hit that meridian in 39 minutes. So we're not going to sit here that long. So we're going to help it out a little bit. Let me go back and set this to like 2 minutes. So what it's going to do is wait till the scope is tracked 2 minutes past the meridian, and then it's going to tell it to flip. Before it does that, it'll do a plate solve and remember the coordinates. And then if you have this guy recenter after flip enabled, then it will do a plate solve and center on the other side. You can also have it do a focus on the other side. I'm going to turn that off right now because you've seen the focus. But with many scopes like my SCT, when you flip it all around to the other side, the mirror probably will shift a little bit. So it's a good idea to have it do an autofocus on the other side. So we'll go back here. We've, I think you can see it's, guiding fairly well. It's taken several frames now. So I'm going to stop this sequence. Oh, let me show you. At the bottom here, let's see. I may have turned it off, but usually across the bottom, it will tell you what frame you're on, how many seconds are left. I don't worry about figuring it out now, but it'll tell you how far into the sequence you are. But oh no, it finished the sequence, sorry. That was pretty quick. So it finished the sequence. So what we're going to do is we're going to move the scope over near the meridian and watch it flip. Or else crash. We'll see what happens. But all right. So I'm zooming out. We're going to go over here. This fella. It's another nice trio of galaxies in Leo. He's getting pretty close to the meridian there. Let's see what. Right, so we're 2 minutes away. Well, we're less than 2 minutes away from the meridian now. So I need to go over here and start it. Why don't we give ourselves a little breathing room for a second. I got to get NINA doing a sequence. So in this case, I'm going to just turn off all this stuff. I don't want it to slew. So hopefully it's smart enough just to start a sequence. So we want to make enough of these that we actually hit the meridian. And yeah, so let's slide them over near the meridian. A little more. That'll be close enough. All right. So right. So what happened was I was close enough to trigger the NINA has, if you're within certain minutes of the meridian, it's going to do the flip. So I managed to trigger that now. And so it's currently set to wait 3 minutes. So I guess we can, if there's any questions, we can talk for 3 minutes. But in 3 minutes, it's going to go through this sequence. So right now it paused everything. It's going to wait for us to go past the meridian. It's going to go do the flip, and then it's going to recenter. Then it's going to find a guide star, resume auto guiding, and start the sequence. So if you're like Roland or what a lot of us are doing, when you set your telescope up to image all night, part of it is it's going to do this flip for you, because I don't want to get up at 3 a.m. and walk outside and have to do this manually. So most go-to mounts will do this. The Skywatchers, Orions, as far as I know, Optron, as far as I know, this works with everything. So let me just stop there, see if there's any questions or comments. How many people, maybe Raleigh can do a check of hands, how many people are doing sort of automated imaging, focusing, and Meridian flips already?
Michael, can you take just 2 minutes to say the difference between NINA Voyager and SG Pro?
Yeah, we got 2 minutes, I guess. So SGP is the oldest, well, Voyager may be older, but for most people, SGP is probably what everyone was first familiar with. And it'll do all the things I've shown you here. It has some additional features that NINA doesn't have yet. So it's definitely more featured. As for what you would typically use, let's say you went to Big Woods for 5 hours and you just wanted to image, I think there's a lot of overlap between the two. My gut is that the NINA and Voyager autofocus are just a little more robust and a little further along than SGP. Now, if you have SGP working, then, by no means change anything. But if I were starting out and hadn't done anything, I would probably download NINA and play with it if I like to play with software. If you just wanted to get something and it would just work, then SGP or Voyager.
Well, that's
certainly.
My question. I have both SGP and Voyager. And before my laptop crashed, I was going to download NINA.
Yeah. Well, I mean, I've used Voyager, and obviously of the three, it's the most competently written, the most robust. It's bulletproof. And for most people, it probably does things in a way that, works with their workflow. It's not as, I don't want to say it's not user-friendly, but it's more minimal in the way its UI is presented. It's more like, something from the late 90s, early 2000s. If you're used to that kind of software, it's perfect because you get right to what you want and then you do it. It has scripting, which allows you to extend what it can do very much. And it almost relies on that to some degree. If you're going to do something where you weren't at the scope, the only choice is Voyager of those three, I would say, if you want to spend money on software. So we're going to flip, hopefully. I'm going to bring up the picture of the scope so I can hit stop if something bad happens. But all right, so we're starting to flip. And yeah, there are times I wish I had a camera out there because, it's showing me something nice there, but who knows what it's really doing out there in the dark. But no. AP spends a lot of time on their drivers. This is pretty solid.
So the big red emergency stop button is.
Yeah.
Stop button.
I've used that because I forget that I had the light box on top of the scope and I'm about to start imaging and I'm like, oh, and then I hit that and usually I get it in time. Sometimes it falls off the deck in the grass so it doesn't get hurt. But all right, so we're about done. So now we're on the other side of the mount, pointing. We're going to be pointing at the same point in space, but now we can keep tracking because we're not going to have that pure collision on this side. And this is where it's very important to have your cables where they're not going to get caught on anything. All right, so it's going to let things settle down. Going to do a plate solve.
I point out that as far as I know, there's no mount that has a command that's called flip. What you really just do is slew to a point that initiates a flip.
Yeah, that's why it waits for you to get past the meridian to just be absolutely certain when you do flip, you're on the right side. All right, so it's saying here that we weren't quite close enough on that first try. So it's going to take it's going to slew again, take another image, plate solve. Hopefully this time we got it. Okay, so now if you look here, it's going to turn on PHD2. It found a nice star. What a nice pattern. Okay, and then so it turned on guiding. So we're going to wait, let the guiding settle to make sure that it's guiding well. And now it's showing it. So now it's going to start taking an exposure. So we're going to do, now I didn't reset this. So we had done 10 exposures before, and now it's going to do number 11 through 25. If you hit this recycle looking button, it'll set that back to 0. So it's going to do 11. It's on 11 out of 25 exposures, and it's almost done. If I go back to imaging here, it should load up that image. Now I just kind of picked a random place. I didn't actually give it coordinates, but that's one of the galaxies that we were nearby. And it's just going to keep going. It kind of gets boring after a while. It's just going to sit here and take images for a while. And that's kind of the point of this sort of software is there is an initial learning curve. You have to train the autofocus. You know, you have to put in you have to fill in all these settings here. You know, your options. Because I've done this a lot for 17 years, it probably took me about 10 minutes to get this all set up and start taking images. So I'm not expecting everyone to get it going that fast, but that just tells me that things were laid out pretty logically. And, you know, I could get it working. Once you get all that set up, then it's a matter of coming in here and framing your target, setting up a sequence, and just hit go. And then in theory, if all the equipment behaves, you'll just start collecting data. So with NINA, it's pretty much set up to just, you give it a list of things and it does it immediately, which is what most of us are doing. So yeah, let me stop there.
Chris asked, have you ever Meridian Flip before beginning a session?
Maybe explain what you mean a little there. I'm not sure I understand.
Chris, are you with us?
Yeah, okay, so the question I had was like, say like your target is just very close to Meridian and you just like shrug it off and go ahead and put it on your opposite side of where it would actually be tracking. In other words, you're putting it, you're pointing your scope at the object on the same side. So your counterweight bar is sticking up in the air, but you know, eventually it's going to be like,
so most of the software, I don't know if Voyager would be happy in that mode. Most of the software will not do that because they're trying to avoid that situation. But there have been times where, yeah, I would. Now the astrophysics driver is very good. It can sync and do things on the wrong side all day long. In fact, it has a setting. Here under Meridian, if you set this number to something like -1 hour, it will actually, and let's say your target was a half an hour off on the wrong side. If you slew to it, it would actually slew to the position you're talking about. And astrophysics thought of this. So, and I used to use that a lot when I would just manually set the sequences up by hand, because then you never have to flip. And most scopes you can get about an hour or so. Let's see, there was a question about, the other thing you can do also here is if you hit this button, it'll do a flip from wherever you are to the other side. So you can set things up that way also.
So the thing, another thing too, this is just like what you're doing there and my astrophysics mount. Do you use APCC a lot? I haven't really touched it.
Only because their ASCOM driver is kind of lame, but so EQMod has Meridian limits built into it. You can set it up so if you forgot to turn the mount off, it would stop before it crashed into the pier. The astrophysics driver doesn't have that. You got to get APCC, which is a program that kind of layers on top of it, and it's worth buying anyway. I was just kind of annoyed their driver didn't have something simple like Meridian limits, but so here you can set up you know, limits. I have them set up over here. If the RA goes 25 minutes past Meridian, it stops and parks. If it tries to slew to a deck less than -54 degrees, which, you know, it's kind of crazy for our latitude, it'll stop. And then I have it set up, oops, sorry, where is it? Oh, down here. I kind of have a constant horizon. I think I set it at 20 degrees, that if it tracks into that horizon, it stops. So it's really useful for those things. It gives you a little comfort that, you know, if you forget about your scope, it won't track and collide with itself. So, it's only 150 bucks. I recommended it. And also, it gives you this cool 3D view, so you can watch your scope, I use that a lot also, just to make sure, things are acting right. All right, so, our sequence has been running here.
One other question.
Yep.
Michael, Doug asked, what kind of focuser are you using to receive that kind of detailed feedback?
Let's see, did I lose this? Yeah. Basically, I bought a stepper motor that attaches to the C8 focus knob. So I don't have an external Crayford or anything like that. I found this worked pretty well. The image does shift slightly when you focus, but the autofocus is moving it over such a small range, it doesn't seem to be a problem. And I have a focus controller which drives that motor. I just built using Arduino, but Moonlight sells a controller. There's several out there, and it just talks to the computer. Just talks every USB to that controller, and tells it, to move a certain number of steps. Like right now, we're at focus position 8100. I could type in a different number here, and it would just move there. So. Pretty standard for most of the stepper motor solutions. I know Moonlight has one. Feather Touch sells a motor for their focusers. Then there's other third-party companies. I think Rigel is one that'll sell you a focus motor that with an adapter that will probably fit any scope most of us would have. And then you just plug that in USB, load a ASCOM driver, and then NINA can talk to it, and you can set up the autofocus like I did. The other thing is, if you were not using a motor to control things, NINA has, I can't show you now, but if you put a Badenoff mask on and took an image of it, and you turn on this analyzer, it would let you measure those. If you're familiar with a Badenoff mask, you have 3 lines, and hopefully they all intersect in the middle. If not, that tells you you're out of focus. Well, this tool will analyze those 3 lines and tell you how close you are. So if you were manually focusing with a Badenoff mask, you could still get pretty close using this tool in NINA. All right, so the sequence is done. It doesn't really do anything. If I had other observations here, it would have changed the filter and just either refocused or just kept moving. I mean, really, that's all there is to it. I mean, like I said, it takes a while to get this set up, but once you've got it going. Now, something I haven't shown you, which is something called a flat wizard. If you had a light box or you were taking sky flats, you could tell it, I want you to take some flats in L. I want you to get 32,000 counts. I'll allow anything from 29 to 36. And you can use exposures between 1 and 2 seconds. And it'll sit there and start taking exposures and adjusting the exposure time until it gets the counts you want. And then it'll just take a bunch of flats. And you can set that up for each of your filters. So if it's, twilight and you just want to take sky flats, you could just turn this on and it would just start hammering through them. And as the sky got dimmer, it would start automatically increasing the exposure time to keep the counts up as long as it could. Or if you put a light box on there, it's the same thing. It'll go through and do that. So when I do this, it uses about 2 seconds for L, 8 for R, and then 4 for G and B. My LEDs are really red deficient apparently, but it's kind of nice because I just put the light box on there, hit go, and then just watch it for 5 minutes. And then it's done. Another nice thing about NINA we didn't see, let me just reset this and we'll start it going. If you're like me and you're using a low power laptop or a little stick PC or something that's not the fastest thing in the universe, most of the software I've tried to use can take 6 to 10 seconds between exposures to just save it to disk. And if you're taking 30-second exposures, that kind of sucks. You just wasted 10 seconds. With NINA, it's very efficient. You'll watch here when it's finished its exposure. It downloaded it. It's already started the next exposure. It used a background process to save it. So it's essentially instantaneous. So, I mean, you know, we have multi-core computers these days. It's kind of insane that all the software doesn't do this already. But now, if you have a very fast laptop and you're not worried about having to say battery or anything, you would never notice this. But when you're out of big woods, it's kind of nice not to be powering a big gaming PC just to download your frames fast. So, yeah, so it'll just sit here and keep doing this until you know, you give it another target. So that's the point of these automated software. Now, if there are any questions, I don't know if people had time, but I think, do you want to show something, Roland, or?
Let's see. We have.
It's all going, isn't it?
Yeah, it's all going. John asked if you had a rotator, could NINA rotate the imager 180 degrees after a flip?
I'm assuming it would. When you set up the framing, you can set up a rotation. And when you do the sequence, there is a rotation field. So I'm assuming it would. I haven't set that up, obviously, but it would seem to make sense you would have to, right? Or else it would be off. Or would it?
Or if you just depend on stacking to fix
Oh, well, yeah. I mean, it would be upside down, but it would stack properly. So you wouldn't need to do that. But so NINA doesn't have any scripting that I know of. So you can't set up rules like that. With something like Voyager, well, I don't know, in Voyager, that might be tricky. Could you script that, or?
I think it's actually an option in the sequence whether or
Okay.
not.
Yeah. Well, Voyager covers most of your bases already. The thing in Voyager you use scripting for generally is you can set up a little more sophisticated rules about, well, wait till this target is at 45 degrees, start imaging it. When it hits 70 degrees, move to another target and start imaging it. And so you can set up some really complicated sequences, which if you're hitting a lot of targets is very flexible. We can't do that with NINA, but NINA can handle more than one target. You know, if you set up, like right now, I just have one target. If I put in multiple targets, there would be more tabs across the top. And when it finished this one, it would just go to the next one and start it. But you can't really control the order they occur in. It just goes through them sequentially. But if you set, you know, if you pick your targets right and you pick one that's coming up as another one's going down, then it would just kind of work out for you.
Yeah, the author of Voyager told me that you know, he's got 50 targets set up in his script, and they're all set to start when they're within 2 hours of the meridian. And he just keeps looping through that script, so that's all he does every night. It'll automatically run whatever is currently well positioned.
Yeah, and so that's starting to get into something we call scheduling, where you say, I'm interested in these objects, you figure out when they're up and the best time to image them. You know, this one I don't care about the moon because I'm using H alpha. This one I don't want the moon up because I'm using L. And ACP is the big daddy of all that. Of course, it's $1,000, but that you could put in all of these things and it will just shake through it all and figure out what to image that night. Voyager's getting close to that. You know, they're going to start adding those kind of features, which is just another nice thing, because at my house, I'll show you my horizons. All right, so this where the cursor is straight up, and let's see, I guess this is, oh, wait, sombrero's up. So this is south, this is north, west, and east. So the deck, this is the outline of my house. because, you know, the deck is to the west, so the house is to the east. So I'm pretty blocked out in the east here. And then in the south, I've got things like a tree that, you know, you can't really image through. So figuring out what time along this complicated outline object will actually be visible, you can do it. It's kind of annoying. If the software knows your horizon, which I don't know if most software does, that's why I ended up writing something. If it knows this outline of your horizon, then it knows exactly when it can pick it up and when it's going to disappear, and then when it can pick up another thing. So that's kind of the next stage in Astro software. Will hopefully these packages like Voyager will start doing that stuff. But if you're just going out in the big woods twice a month, you don't really need those features. NINA or SGP will let you set up a sequence. It'll do the focusing and flipping for you. All right, so it's, well, like I said, this thing's just gonna keep going, so I'm gonna stop it. Yeah, like I said, you know, I'm pretty impressed with it. You know, I'm really happy. The group of people working on this are all volunteers, and they visit, there's something called Discord. It's kind of a chat room. They seem to hang out there. So if you have a question, you show up there. Like if I had a problem right now and I went there and I could explain to them what's going on, there's probably someone there that could help you out. Now they're not paid, so you can't treat them like, you know, a support line or something, but they're happy that people use their software and are happy to try to help out. At least that was my experience. Let's see. So I just noticed the sombrero is up. Sombrero Galaxy. So if I threw that into the sequence and went here, you'll see it's got it. And if I, let's see, so it made a new sequence. So let's just do 15 at, I mean, we have software like this, you can almost use it just for visual astronomy because you can just go around and take a few frames and get an idea what you're looking at. All right, and we're not going to focus or do any of that nonsense. Now let me bring up my cheat sheet here. It's going to have to do a, it won't have to do a flip, will it? Yeah, we'll have to flip. So, oh, sorry. I got to tell it to slew. Otherwise, I'll just start taking the image of where you are. All right, so in theory, let's flip this around so we're looking, all right, so we're looking from the north at the mount. Sombrero is somewhere over here where I put the mouse. So it's doing that flip right now. So you can see to get to a new target, I typed in the name, I put the box around it, loaded in the sequence, and then hit go. That's pretty much all there is to it with NINA. If we go over here, let's see. You can kind of see the telescope position here. It's moving around. It's in the eastern sky. It's pointing at the side of my house right now. But it's going to pop out and eventually we'll end up way down here. I'm kind of lucky, at least. In the south, I don't have much. So I can get pretty low in the south, which is kind of where you want to be able to do that. Hopefully my cables are long enough I don't rip something out here. All right. So it's going to start the plate solving. Well, there it is. So we had to go pretty far, so it's off a bit. So it's going to have to do another slew. Hopefully it'll move it over here. So it's taking that second exposure. And it plate solved it. It's kind of pretty much dead center. And so it's going to give up now. It doesn't need to do that. It's not going to focus because I didn't tell it to. So it's already starting to take exposures. So let's see if we can find the center here. Yeah, we're getting close.
You have guiding stopped, right?
Yeah, I don't have any guiding. So here's the sombrero. Oh, yeah, I didn't focus, so the stars are starting to get big, but so here's a 30-second exposure of the sombrero. You kind of, if you don't know what I'm talking about, you can look it up with Hubble and get your eyes blown out how amazing detail they had. But you can see basically it's edge on, it has a dust lane, pretty prominent dust lane to it. So that's a 30-second exposure. That might be a good target. So anyway, that's pretty much NINA, you know. If you wanted to, you could manually start guiding, right? I could go over here and just tell it to start looping. If there's a star nearby, let's see. Yeah, there's a few. So the newer version of PHD2 added this button where it'll auto select. And then just start, it'll just start guiding. Now NINA won't know anything about it, but since I'm not dithering, it doesn't matter. It'll just be it in here.
Your audio got a little warbly again.
Oh, sorry. How's that?
That's good.
That was good.
Okay. Yeah, so now it's going to sit on M104. Yeah, I guess it's still talking to the server because it's showing me the progress. It's just it didn't turn it on. And that's kind of handy. Sometimes if you screwed up something, you can go over there and fix it in PHD2 and hit go, and it'll just keep running. Let's see, I didn't show. So there's a statistics window. When we were talking about optimal exposures the other night, the median of the background is what we're interested in, is 1300. So I'm hitting that number pretty early because I'm kind of down low, shooting over town, I guess. And it's the L filter. So if I were shooting this for real, I'd probably be doing 60 seconds just because I don't want to stack 1,000 30-second exposures. I might be able to stack 500 1-minute exposures. So that's pretty much the deal there. I mean, you know, this is just the image viewer of what's coming in. I didn't show, this is kind of neat. This takes the corners and the center of the frame and shows you, it's called an aberration spotter. If you're trying to figure out how to get your flattener in the right position, you would slew somewhere with a lot of stars and start taking frames and focus the center. And hopefully the stars, these frames are along the very edge of the sensor. And it just took a little crop and then stitched it all together. So this is showing you what your stars in the center and along the edges look like. And if you get your corrector in the right place, ideally these would be nicely focused as an addition to the center. So that's kind of a neat little tool they added. You can also, if you hit this button, it'll plate solve the current image. I don't want to do that because the sequence is running, but that helps you. If you're just kind of on the fly trying to get centered on the target, you can use that. And it does support subframes, meaning if this is a small target, I think you can set it up. So let's say you just wanted to take this image. Voyager lets you do that as well. So I don't waste this space taking, you know, this whole image. You can set that up also. I haven't used that yet, but if you do that, then you end up taking flats and darks for that subframe. And since I already have a set of darks and flats, I don't want to redo those. So I always take the full frame. I feel like I'm babbling now. Any other questions?
It's all quiet.
Yeah, so what I'll do now is, you know, I have a chair in my office that is comfy to sleep in. I'll set the laptop up next to it, maybe set the alarm for 3 hours. Wake up, look at the laptop. If everything looks like this and, you know, things are working, I'll just go back to sleep for the rest of the night. Or check, if I think of any clouds coming, I'll check the radar a few times during the night because I don't trust technology with that stuff yet. I got to see it for myself, but I can drive it all from inside. I don't know what haven't looked at the clouds. Have you got anything on your cloud sensor over there, Roland? Or
I haven't got that set up yet. You just prompted me to check the forecasts. And
I'm looking at the satellite loop right now.
okay, this call. Of,
We're good.
Oh,
There's some stuff moving through Northern Virginia, but we're clear in North Carolina, so that's good.
I
yeah,
have a question. How did you set up your house and trees? I think I've asked this before, but I'll ask again.
Yeah, well, I waited till it was a real full moon when I didn't feel like I could do anything else. And then I went, in the past, I would go into Carte du Ciel and just kind of use the hand controller and the slew in a certain direction. And I usually have something like a program. I think I actually use PHD2 with my little finder guider. I just had it on infinite loop. And as soon as I saw a tree enter the, because if it's a full moon here, the trees are nicely backlit, so you can see the silhouettes. And I would just move it in each azimuth about every 10 degrees until I saw trees, and it's noted that I went over here and just wrote down the altitude and azimuth. With this, though, APCC has a nice thing where you can tell it, you can just say, go to this altitude and azimuth. So I would enter an azimuth and maybe, let's say 45 degrees and hit go to, and then I would just start decreasing the azimuth, the altitude, until I hit a tree. Then I'd move this by 10 degrees and then keep going. Takes a little while, but you know, and I've updated it. You know, my trees have been growing. I think it used to be down here somewhere,
Yeah.
but I'm losing.
I just did it with,
taller.
I just did it with my iPhone and
Oh yeah.
and took, you know, every 10 degrees I measured the angle.
Oh, cool.
Where, you know, and I just went all the way, wrote the numbers down and programmed it manually.
Yeah. So you could do that during the daytime. Yeah, and I know there's software that will take a picture and convert it, but yeah, so I don't know a secret answer, Steve, other than just kind of sampling it. Yeah. It doesn't take too long. And it doesn't have to be real accurate. I mean,
Yeah.
You know, and, you know, along some stretches, it's pretty constant. So when you slew there, you just have to move up a few degrees and then you get into
Well,
clear.
I'm pretty constant to the south, but to the, I guess the west, I'm not. So I have to watch out for that because the trees are growing about
Yeah, like for mine in the north,
well, my house is to the north as well. So.
like the screen porch has a bit of a flat part, and then this is the roof line going up. There's a tree over here, but you know, I can see Polaris just barely, which is the important thing.
Okay. All right.
So that's what we're, oh, there's a comet down here. Pan stars. Oh, I kind of lost interest after that guy fizzled out, but I guess it's still there. I see people taking pictures of it. Well, I don't want to keep everyone up late. If there's anything you want to see or questions, I'm going to be up a while, so I can certainly stay here and answer. But hopefully that gives you an idea of what you can do with NINA. And once you get it set up, it's a pretty slick little package.
Can I ask you a question?
Sure. Yes.
You're running multiple programs. Where are you getting your time from? Are you syncing off the mount, or are you off the computer, or are you mixing and matching?
Yeah. So I have the computer set up to use the time service. You know, I think that's a default in Windows these days, but it's using some internet time server, so it's within a few seconds, hopefully. The software for the mount here will, when you first start up and connect it, which I didn't show, it initializes the mount. And part of that is it sends it your coordinates, which I set up here, my location. And it will also send the time to the mount. So I guess it's all based on the computer.
Okay, so because I know I read some instructions that you can sync the mount off the software, the Cirque du Soleil, whatever it is, software. You can sync those two together.
Yeah, I know what you're talking about.
I just wonder whether there was any effect in that or not.
Oop, I didn't like that. Yeah, that's somewhere in here, isn't it? I don't remember. I guess you could click this button, set to telescope, get from telescope. I set these up probably a decade ago and haven't looked at them since. So I'd have to play with them on a new computer to get them right, probably. But
well, then the time really is an important factor, I guess.
well, for things like the Meridian Flip, obviously, it needs, it needs to know your time. Also, it needs to know your longitude fairly accurately, because,
All right.
If you're off in longitude, that's equivalent to being off in time. So.
Yeah, it's interesting. And the NINA program, does that care about time?
Well, it does in the sense of, when you set up a sequence, for example, it will, it tries to estimate, like here, it's actually filled it in. So the download time is 1.15 seconds, not 6 or more, which is, I love. But what it does is, it figures out how many exposures you're taking. So, 15 at 30 seconds. So that's 7.5 minutes. Then it added 15 times this number to work out how long it's going to take to complete this sequence. And so it'll fill all that in. So if I refresh this, you'll see over here now it filled it in. To take those 15 frames would take 7 minutes and 47 seconds. And so it's thinking about it. So it's telling you it'd be done at 10:20. But other than that, it doesn't really keep up with time. You can set a delay. Like if I set this to like 600 seconds, it would wait 10 minutes before it started. But I think it's kind of assuming your mount knows all that information, and it's just sending it RA and DEC coordinates, and the mount can figure out where in the sky those things are, if that makes sense.
Yes, thank you very much.
Yeah, of course. Yeah, I mean, I don't have much else to show at this point. I can still answer questions. Still around?
Yeah, looks clear.
Yeah.
Building mounts in the back of in your yard somewhere?
What's that?
I was asking Roland, you're building piers or something at your house?
I've got the guys from Backyard Observatory has been quarantined. I should actually have a roll-off roof observatory under construction by now, but it'll probably happen within a month if all goes according to well.
Oh, okay.
But actually, things are working pretty decently from the deck here. I mean, I'm like Michael, set up on the deck, and so far it doesn't really seem to be affected by shaking because it's not on solid ground.
Yeah, my deck's only 3 feet up. It's not, it's not like a second or third floor deck or something. And yeah, I was worried about it initially, but unless I walk on it, it's pretty. I don't notice it. I mean, you can see the guiding. I mean, it doesn't seem to affect it there. It makes it a little tricky doing polar alignment because everywhere you stand, I try to stand in the same place, far away from it every time I do an update in SharpCap, but it has to affect it some. So that's why I don't sweat polar alignment too much, because I know it's going to shift when I leave. Yeah. Who knows, when the scope flips to the other side, the weight might slightly change, and that could change it slightly, but I've never had a problem.
Get one of those high shelf ladders. They have it like Lowe's and Home Depot, and just roll it up beside your deck.
Yeah, I mean, we're guiding along all right. Early when I started doing this, I was tempted to just cut a hole in the deck and run a pier through, but that wife wanted to be able to if I moved the scope, set up a table or something on the deck. So that would be hard with a hole in the deck. So we didn't do that, but we didn't have to. It works pretty well.
Have you seen the Voyager web dashboard, Michael?
Yeah, I have, but what you want to, let me get out of here.
I can show that.
If you want to do some stuff.
Yeah, we're.
You don't want a free Starship auto guider? Beat the hell.
I thought you collected those.
No, I've gotten rid of all but this one now.
No, I've got mine still. I got a Me DSI if I'm really desperate.
So I think this is showing now, right?
Not yet.
Not yet.
I still see you.
I've got a big 1 on my screen here.
I can see it in your glasses.
It's almost as good. Let's see. Oh, okay. I got to click the share button. Bang.
There you go.
All right.
Nice.
So this is this is actually Voyager running. So this is the desktop screen as shared. So we're going through multiple levels of sharing here. And as you can see on the left here is the Voyager application itself, which I can make full screen. And at the top here is this script that Michael was referring to. And it's really a sequencing capability. So what I've done is put together all the sequences that I need to run for an entire evening. And when I start, it'll connect up. It'll automatically take my dusk flats using sky flats. It'll do an initial slew and then do a blind solve and sync them out so it is sure it knows where it is. Optionally, it'll do a guider calibration, which I just skip over most of the time now because you really don't need to recalibrate every night. And then it'll run sequences. And for each sequence, I've got conditions for when to start, when to stop, what happens if there's an error, and then at the end of the night, go all the way down here. It will take my dawn flats and park them out and warm up the camera, and we're all done. And it's also got some emergency suspend and resume events built in. So if you get a notification from the Cloud Watcher, once I get that reinstalled, that says, hey, it's overcast now, it'll come down and run whatever you got in this suspend section. So what I've got there is, close the flat device if I've got the flip flat installed, stop tracking, and wait. And then when it gets a resume, which comes from the Cloud Watcher that says, hey, the clouds are gone, it's been gone for 15 minutes, let's start up again. It'll start tracking, open the flip flat, which will, when I get the observatory, that'll be open the roof, and then just go back where you were and resume. When it goes back, it's smart enough to know that if the time for that sequence is passed, go ahead to the next sequence. So, if you're shut down for 3 hours and you were trying to run a 2-hour sequence, it'll try to run the next one in your list.
Roland, define Cloud Watcher.
Yeah, so Cloud Watcher is actually a name of a product, AAG, Lunatico, Astronomico, these guys in Spain make this. So it sits there and takes infrared shots of the sky. So it's looking at sky temperature. And if your sky temperature goes outside of a given range, it knows that it's become overcast. So it'll detect overcast, broken conditions, clear conditions, and then you can do whatever you want accordingly.
Internet thing, or that you somehow connect into the software, or what?
Yeah, it's connected into the software, so I don't know how much I can. I mean, I'm running live now, so I don't know how much I can show in setup, but like right now, I'm not managing. Yeah, it's not going to let me change this since it's live.
Yeah, I understand. All right.
But in here, it's got a big table where you can tell Voyager, hey, in any combination of conditions, rain, wind, sky, overcast, cloud cover, do this, where this might be suspend, resume, or exit, where exit will say, hey, just shut down. We're not even going to suspend.
Okay.
So I know it's getting late here, but in addition to that scripting area, Voyager also has an on-the-fly panel. So this is where you can do things independently of the script. So you can define and run a single sequence. You can move your mount around. You can plate solve. You can look up an object and go to it with plate solving or without. You can do autofocus. Pretty much everything you want to do that you could do, manually, you can initiate as an action here. And there's also this viewer. So this is what I'm taking live now is M108 and M97. And this is an independent program, but when you finish, when it finishes taking a shot, so down here in this monitor window is a log of what's going on. So you can see it's telling you that it's guiding and it's did some dithering. The blue is where it's doing the exposure, and then when it finishes the exposure, downloads the next shot, and it'll show the image you just downloaded there. So like right now it's actually doing. So here you see, please wait loading. So there's the image that it just took, and you got a histogram over here, and you've got I don't know if you can see this part of the screen, but
Yeah, Voyager didn't originally have a viewer, now it does. Is that right?
Yeah. So it's got the the image stats there. So that's the super quick look at the view. But then the other thing they did that's fairly new is this web dashboard. So here at the top it shows you what it's currently doing. It's taking an exposure of M97 and 108. Here's I don't know, I've got everybody's camera view here, so I can't see myself. So here you could actually put in the name of an object, and you could then do a local find, or you could use Sesame online internet find. Local find is if you're connected to Cart2CL or the SkyX. Here's what's going on with your mount. You can control your mount from here. And then this is their object framer. So, what was it, M104 you just looked at, Michael? So if I did find M104, there's the sombrero. And here's my coordinates. I can rotate the position angle. I can move around, to get the framing that I want. And then a nice thing they've got here is this RoboClip database. So I can say, hey, get the data from that field of view. And then he's actually keeping a little database where you can create groups of targets with their coordinates, with the target name, save it to the database from this view, and then retrieve it when you're setting up your sequences inside of Voyager. And if this is not particularly something I'd want to do a mosaic of, but if I wanted to do a mosaic, I could set that up as well. And it would then, I can go into RoboClip and I can save all these positions and then create a sequence that'll run through these 16 different positions of the mosaic. So that's fairly new, the framing wizard. This is the last from the web browser now. I could be anywhere without a desktop screen share. And that's my last image that came in, my HFD. Here's what's going on with the camera. It's currently taking a shot with the blue filter. Here's the progress, 55% on a single shot, 9% on the sequence. My camera cooling, my auto guider, so that's where I just did a dither. They don't have the focuser on the website yet, but he's working on that. And then here's like the image statistics. How are we doing on the star size? And then that same kind of detailed log step by step of what's going on. I like the fact that he color codes the log too. So if you've got a problem, it'll show up in red, which is helpful if you're just looking across the room. So that's a quick look at what's going on with Voyager.
Thanks, Roland.
Yeah.
Yeah, so that definitely, if you're like Roland, you're going to have permanently set up scopes. You need to have that ability to get the most out of using them.
Yeah, I think unless you want to, image unattended, it's probably overkill. But if you want to image unattended, I've used a lot of different pieces of software, and this was so far head and shoulders above the others in terms of reliability for just running all night without you sitting there.
Well, that's the nice thing about it is you don't find yourself having the program hang on you, or it can't talk to some piece of equipment and then you have to restart everything. Yet I never had that happen with Voyager. I know you were having problems with SGP. Could have been hardware problems, but still, when you switch to Voyager, you don't seem to have those problems now.
Nah, no, it just it cleaned right up.
All right. Think we ought to wrap up, or?
Yeah, almost 10:30. I know we're probably got the night owls are the only ones left here. It's still early, but
Yeah, I might still take advantage of the night. So I'm thinking about what I want to put up on it and leave it running. So
yeah, it's turned out to be a better night than I expected.
Any clear night I'll take.
Yeah, I thought we were going to crap out around midnight, but it looks like we might go all night here.
Yep. All right. Well, we don't have anything planned for now, but if anyone has an idea for a reason to meet up like this again, just put it on the list. We'll think of something. Get through this. Not being able to meet together, at least. This is nice. So
yeah, that's great. Thank you, Michael.
You guys have a great night. Thanks.
All right. I'm going to stop the recording and end the meeting. Thanks, everybody.